Hi, I'm Kit Cox with Mini Circuits Japan in Yokohama. In this step-by-step tutorial, we'll walk through how to set up Mini Circuits 250-watt turnkey RF energy solution comprising the ISC 2425-25 Plus signal generator and controller and ZHL 2425-250 Plus solid-state amplifier. To begin, we'll make our connections between the signal generator and the amplifier. Start by connecting the generator's SMA RF output jack to the amplifier's MCX RF input jack using an SMA to MCX RF cable, such as a Mini Circuits 06-12SM MCR+. Also, connect the generator and amplifier's I2C bus together using the included Molex to Molex cable assembly. This connection seamlessly integrates the generator and the amplifier into a single, high-powered RF energy generator that you'll control from your fingertips. The DB9 connectors on the generator are used to connect multiple amplifiers for higher power output. We'll leave these alone for today. Next, connect the N-type RF output connector of the amplifier to your applicator or cavity's RF input. If you need assistance finding the right cable to make this connection, the Mini Circuits Applications Department will be happy to assist. Now, let's provide power to our two devices. To power the amplifier, you'll need a 32-volt DC power supply rated for at least 16 amps, wire larger than 14 American gauge, and some hardware specified in the amplifier datasheet. To power the generator, you'll need a 5.5-volt DC power supply rated for at least 1 amp. Use wire to connect the supply to the 2-pin terminal block connector included with the generator. Note that the generator can operate without a dedicated power supply using the USB bus port alone, but its RF output power will be reduced. For our final physical connection, connect the included USB-A to mini USB cable to connect the generator to your computer. We've now finished the physical setup of the system. Now, download and run the latest control software for the generator from the Mini Circuits website. It's available for Windows and Linux, and has a simple touch interface that's both mouse and touchscreen friendly. For Linux users, refer to the Quick Start Guide for the necessary dependencies. When the software starts up, it should automatically detect the USB-connected RF energy system. Take a moment to familiarize yourself with the control interface. The system status is shown in the lower right-hand corner. It should read OK. If you see errors in the lower right-hand corner instead, take action to resolve the errors as needed, or contact our applications team for assistance. Errors clear automatically once resolved. Once we see the status of OK, we're ready to get started. Let's use the S11 sweep feature to easily find the most absorptive RF frequency to apply to our load. Tap the S11 sweep tab at the top of the GUI and keep the start and stop frequencies to the full range of our system, 2400 to 2500 MHz. Keep the step frequency to 1 MHz. For the output power, we suggest setting the RF output power during this initial sweep to something lower than your intended power level. This will avoid stressing the generator with all the reflected power we'll get during the scan. So for a 250-watt application, let's set the sweep power to 50 watts. Tap the sweep button. The system will sweep 50 watts of continuous RF energy upon the load from 2400 to 2500 MHz. And measure the reflected, or S11 power, at 1 MHz steps. Once the sweep has finished, the GUI will display a graph of the reflected power across band. In this example, we can see the point of lowest reflection is at 2470 MHz, with only about 12% reflection, so let's use that frequency to irradiate our load. Tap Home, and then tap the frequency and enter the frequency of 2470 MHz. In this example, we'll heat our load using the maximum available power, which is 250 watts. Tap the power and enter 250. Now, for safety, check that the applicator's door is securely closed and that no energy can radiate outside the cavity. Tap the RF on/off button to switch the output power on. As the material is irradiated, you can see a display in the GUI of forward power, reflected power, and a calculation of reflection percentage. To stop, press the RF on/off button to switch the output power off. As the material heats up, its physical makeup will change, and this will often cause its ideally absorptive frequency to change along with it. That's why our system also includes the digital locked loop, or DLL feature. With DLL, we'll keep changing the outputted frequency with laser-like precision to make sure that a maximum amount of the system power goes toward heating the load, and wasted, reflected power is kept to a minimum. Let's use that feature now. To use DLL, tap the DLL tab at the top of the GUI. Enter the starting frequency from your most recent S11 sweep and start frequency. Set your desired allowable frequency range in lower and upper frequency limit. We suggest the full 2400 to 2500 MHz if your applicator permits. This is the default setting, so we don't need to change it. We'll continue to use the full RF power of 250 watts and a step frequency of 0.1 MHz. Tap the DLL button at the bottom right-hand corner of the GUI, and then tap the RF on-off button to turn the RF power on and begin irradiating the load with DLL tracking turned on. The outputted frequency will change as the load's material changes, and you can monitor the changing frequency in the bottom right corner under DLL frequency lock. Now you're ready to use your system for the intended application. Keep an eye out for more videos on this topic. I'm Hit Cox, thanks for watching.